Hi, welcome to video R-5, even and odd functions. Today we're going to talk about, explain what is the symmetry between even and odd functions and how does that work graphically. And then we're also going to talk about determining if a function is even or odd using the definitions of even and odd functions. So to start, we're going to kind of talk about what does the behavior of a graph do if you change essentially the positive or negative values of x. So for example, we have for the first graph, that's a parent function, we have f is equal to square root of x. That's what that looks like. So hopefully you guys got that. Now that right there, it only stays in that first quadrant because only positive values can go in the radical outside of imaginary numbers. You'll deal with that later on. Now, what happens if we do negative square root of x? Now, what you want to think about here is that this changes the entire y values of the function. Because if you think the square root of x, that was giving us positive values. Now we have the square root of x multiplied by that -1. So what's actually going to happen is it's going to flip over that x-axis. And so why don't you go ahead and graph, what do you get for k of x when you have negative square root of negative x? What do you think is going to happen there? Now, hopefully you kind of are thinking, oh, well, the negative is with the x values. So in order to get a positive value underneath that radical, you need to have negative times a negative to get that positive. And so you should actually have this flip over that y-axis. Now, for the last thing we want to look at is, what do you think that graph of negative square root of negative x look like? Based off of what you've seen so far, this is kind of a little bit of a pattern, perhaps. What do you think that last one's going to look like? Go ahead and pause the video and then come back and see the result. Welcome back. Hopefully you found that the function is actually going to go and reflect over that x-axis. So it's the function k of x that gets reflected over that x-axis. So let's see, what is the definition of an even and odd function? So it seems to be having some reflective properties. So an even function is going to have symmetry across the y-axis. So symmetry across the y-axis, and that means it's even. Now, the way that you can think about this is the function of positive x's is equal to the same function of the negative x's. So you still get the same function if you plug in a negative x. Now, if you have an odd function, what happens is a little different. So an odd function, it does have symmetry, but it's over the origin. So it's a little different. It's not necessarily a reflection over the x-axis, but it's a reflection over the origin. So when you plug in a negative x, it actually creates the entire function to be negative. And so that's actually a very unique thing with odd functions, is that when you have negative x's, the whole function turns negative. So now using these definitions, we're going to see if the following functions are even or odd. If you're not one or you're not the other, what might you be? Well, let's see what happens. So the first thing we're going to do in order to test it is you're actually just going to plug in a negative x, because as you can see, that's really what changed things here, is that when you plug in a negative x, if you still have a positive value or you still have the same value, it's even. If you plug in a negative x and get the opposite value, it's odd. So when I have f of negative x, I get that this is 1 over negative x, which is equal to negative 1 over x. So f of negative x is equal to negative f of x is what I discovered. And so if this is the case, what I have here is that this is going to be odd. Okay. Now let's look at, okay, I have f of x is equal to cosine of x. So when I have f of negative x is equal to cosine of negative x? Well, the negative values of x, the respective negative values, do give me the same positive values here if you look at that f of x, or sorry, the cosine graph. And so f of negative x is actually going to be equal to positive cosine of x. And so this is the case that f of negative x was equal to the function f of x. And so this is even. All right. Now, let's go ahead and moving right along. I'm actually going to go over to this f of x equals x cubed plus x squared plus 1. So I have f of negative x, and that's going to be negative x cubed plus negative x squared plus 1. So this is going to become f of negative x is equal to negative x cubed plus x squared plus 1. Well, okay, well, is that it's not the same as the original. So let's see if it was multiplied by a negative. Let's see, so multiplied by a negative, that would be negative x cubed minus x squared minus 1. So it doesn't appear to be this, and it doesn't appear to be this. So this is what you would consider to be neither. Okay, so go ahead and you have 1, 2, 3, 4, 5 more examples. See if you can figure out these 5 other examples on if they're even or odd, and then meet me back here once you finish those examples. Welcome back. So, oh, looks like I forgot a couple. So let's go through a couple of the ones that I have solved already. So when we're looking at the natural log of x, the natural log of negative x actually does not exist. So this would be a case where this is neither as well. Now, in the case of the absolute value, we have h of negative x is going to be equal to negative x minus 2. And so this is actually a tricky one. Now, what might be helpful for you to do is, okay, well, let's look at the graph of it. And so if you look at the graph here, those graphs are reflecting and have symmetry over the y-axis. And so if we look back to symmetry over the y-axis, that's going to be an even function. Okay, now I'm going to go up to the top where we have f of x is equal to the cube root of x minus 2. So f of negative x is going to be equal to the cube root of negative x minus 2. So we can actually do something kind of clever and creative here, is we can actually do the cube root of negative 1 times x minus 2. Now the reason why you want to do that is because you can take the cube root of negative 1 and pull that negative outside. So you have f of negative x is equal to negative cube root of x minus 2. Now again, this isn't the opposite of that function. This isn't the positive value. So this is actually also a neither. Okay. Now, let's go to the sine function. Now this is also one that I want to encourage you to graph. So if you're looking at the sine wave, we want to make sure, let's make sure, oops, we have enough space for some negative values as well. There we are. So we have pi over 2, pi, 3 pi over 2, 2 pi, pi over 2, pi, and let's go all the way 3 pi over 2. Okay, so as you know, pi over 2 is giving us a 1, pi gives us 0, 3 pi over 2 gives us negative 1, oops, and 2 pi gives us 0, and it continues on in this fashion. Negative pi over 2 appears to give us negative 1. Well, negative pi still gives us 0. And oh, hey, negative 3/2 of pi gives us the positive value. So what we get here is that m of negative x actually gives us the negative sign of positive x. And so this would be a function. All right. So that is all for the even and odd functions. You have a couple of problems on your homework for tonight, and good luck. I'll see you for R6.